some small LED strobes. These came from a supplier called Premium Good, which the word good almost makes me think, is this Banggood again? Anyway, they weren't that expensive, I just added them to an order because I thought the wee aluminium housings looked nice. So here they are. And I've already taken LED out of one. This is take 2 because I was videoing this before and it came to taking the lenses off, and yeah, it's not easy taking those lenses off, as I'll come around to afterwards. So this is the sort of case it comes in, the packaging with it. So let's get a 12 volt supply and show you it strobing. So it's got this little electronic module here. Let's see if I can get the polarity right, that'd be quite handy. Hopefully it has polarity protection built in, but you just never know. And strobe. So they both just strobe together. They don't strobe backwards and forwards. And they're quite nice. They look okay. Just get those leads back out the way. Now, what is a bit disappointing about them is that the LEDs, although the lens has a really good effect, the LEDs are not dead centre to the housings. And initially I thought, is it just bare 1 watt LEDs? Because looking through the lens you couldn't really see the star as such, you could just see the LED. And I was expecting it when I opened it up and saw the that it was a small star. It's not the standard star size. This is what I'd call pretty much a standard Luxian star, and this is a miniature version. And it made me wonder, given that this is loose in here and doesn't fit, and this is actually too tight, maybe you could press it in, but I think if you pressed it in, it'd be a bit sort of a bit messy. I wonder if it's designed for this type of LED housing, which is I'm not even sure what standard this is. I've just ended up with one of these in my collection of LEDs, and that fits in fairly accurately, and when the lens is put over, the LED is pretty much central underneath it. The wiring, there's a hole. It's not waterproof at all. These wires are basically fed in, soldered onto the LED, then it's pulled back in, the LED's just placed down there. There's no heatsink compound, but having said that, they are strobing, so the power dissipation isn't going to be immense. These are in the connectors, little plug-in connectors too, which is quite nice. And it comes with screws for screwing them onto your vehicle's bodywork. So let's take a wee look at the controller. Typical little sort of everything just squished into one of these little boxes type thing. A little 8-pin chip, single-sided board. Right there, that looks like a polarity protection diode. Yep, and that's feeding LEDs as well. The positive is coming and going through that diode, and then it's going straight to the LEDs through this 7.5 ohm resistor. The LEDs are in series. Right, okay, let's do the maths. It's a 12 volt supply, minus the 2 LEDs, 3 volts each, 6 volts, 6 volts to drop across, what did I say that resistor was? 7.5 ohms. 7.5 equals, it's running them in bursts at 800 milliamps. Probably closer to an amp if you consider the slightly higher voltage of a vehicle. So yeah, it's overdriving the LEDs, but they are just strobing. They're not a very high duty cycle. The circuitry itself, let's see if that is a PIC microcontroller. I very much doubt it's got a number on it because they just never do. It's always these little PIC microcontroller type chips with no number at all. Is this going to be a different one? No, in fact the top just looks a bit rough. No obvious number. Nothing scrubbed off the look of it, it's just one of these random unmarked chips. But I can guess the circuitry, because I'm looking at this and I'm seeing a resistor. I'm seeing what could be a zener, a little smoothing capacitor, or I wouldn't even call it, in a sense it is a smoothing capacitor. The chip, a resistor and a transistor. So let's get some values, and I'll doodle the circuit diagram for this down just as, without even tracing it out. I can just guess what this is. So plus volt in and 0 volts. 0 volts goes straight through, plus goes through a diode as soon as it goes in. It will be feeding straight through to the resistor to the LEDs, which actually no, the LEDs I've screwed up already. The LEDs, that'll be one LED, just ignore that bit, that messy bit, and the other LED, because they're in series, they're not in parallel, and I'm guessing they're going straight into a transistor, pulling it down. Then there's a resistor there being controlled from one pin of the microcontroller, probably a PIC12 or clone. That will be referenced to ground. The input will have a resistor. That was that 7.5 ohms? Yeah, I think it was. Resistor Zener, and the point of the resistor in Zener is that the resistor will limit the current through this Zener, and the Zener is a diode that clamps at a specific voltage when it's reverse biased, and that's probably round about 5 volts, I'd guess. 5.1 is usually 5V1 is a very common sort of value, and then there's a little capacitor there, maybe 10 nano, 100 nano, just something just to smooth it a little bit. The microcontroller, the resistor, driving that transistor. So let's see if we can find some values. First of all, the resistor that's limiting the current to the power supply. There's the diode, which is an M7. It's a 560 ohm. So that's 560 ohm. The dinky little capacitor doesn't have anything marked across it. We can actually power this up and measure the voltage across the Zener though. If I go across to the output, to the transistor, where is it? Oh, the transistor is unreadable because it's got goop all over the top of it. And its resistor is also 560 ohm. So doing a little burst of maths again, if that is a 5 volt, let's find out. Let's power it up. We don't even need to have the output flashing to do this. I can simply connect that to there, that to there, power it up with 12 volts, get a meter, I'll move the meter across to here since the lighting is better for it that way. Is that going to show up? No. I shall angle the meter back towards the lights, that should work better. Oh, that's better. So that's set to volts DC, so the incoming supply is going to be about 12 volts. Yeah, 11.87. So I'm guessing if I just put this across this little Zener thing, I should get about 5 volts-ish. 4.3 volts. Yeah, that's alright. They've probably used a 4.3 volt Zener, because it doesn't have to be 5 volts. So how much current is that circuit taking then? Well, if it's a 4.3 volts, and say the supply is 12 volts, then the 12 volts is dropping 0.6 of a volts across this diode, so that starts off at about 11.4 minus 4.3, 11.4 minus 4.3 equals 7.1 to drop across this resistor, which is a 560 ohm resistor. I equals V divided by 560 ohms equals, it's 12 milliamps. Let's say 12.5 milliamps. And working on that, the dissipation of the resistor is 12.5 milliamps, or I'll use the full thing, times 7 point, was it 1 volt equals, yeah, dissipation is 0.09 watts, so nothing, you know, it's really, really negligible. So yeah, it's a simple enough circuit. It's a neat little unit, but most of all, I really like these little aluminium housings. They're chunky, they're really robust. It's almost as if they're ribbed, as if it's just something else designed to clip over the front of them. But these lenses do make a big difference, and they do just seem to have a tiny layer of adhesive just put in the edge of them and then just sat in and just glued in over the loose LED. I think I might have preferred to see the LED more centred up, to use the correct LED and stuck to the back with silicone, because the size of it is such that the lens, when it's stuck in, doesn't really press down onto the front of the LED. I don't know if that would be any different with the bigger LEDs. No, it wouldn't quite be there, I don't think. Maybe it would, not 100% sure. But they're nice little units. I like the housings anyway.